Hi everyone. There is a test about trigonometry. I will quickly explain the things, most basic things about trigonometry. This is not a normal teaching learning video. So first here the angles. First you should know the angles. You already know that 30 degree, 45 degree. You already have heard about these things. So the angles comes because of the circle. We find them. So full circle we explain it as a 360 degree. And then in history, there are some other measurements. They before 360 degree, probably they used some other numbers, perhaps 500, 400, 600, 700. So there is another that it's in the book 400. We call this as grad, 400 grads. So half becomes 200 grads. So there is this other thing, which is the special number pi. Since you know that it is made, we got it from the circle. There's another idea to show the full angle as 2 pi. We mean with 2 pi the full circle when we use the pi as an angle, not a number. So then half angle becomes 1 pi. Half circle part becomes 1 pi. So half circle part is also in degrees 180 degree. There are the types of questions which is we want you to convert 120 degree into radians, or this is an angle in the radian form. We want you to convert this into the degree form. So for these angles, you need to know that there is this relation. Half circle 180 degree and half circle is 1 pi. If I have something like 120 degree, if I want to know how to show it in the radian form, so I just put an x over there and make a cross product. So before we're doing this, you simplify them with 6 and 2 and 3. So 2 pi equals 3x, 2 pi equals 3x, so 1x equals 2 pi over 3. So 2 pi over 3 is a symbolic expression. It shows 120 degree in the measurement. So, but if you have 5 pi over 4, from radian to convert to degree, it's a lot easier than this one, which is we know that the pi is corresponding with 180 degrees. So you simply remove pi and insert 180 degree instead of it. So it becomes 45 degree, 5 times 45 degree, 225 degree. So introduction of the first thing about trigonometric ratios, sine, cosine, tangent, and cotangent. So you can write on these ratios only inside the right triangle with 90 degree. So in the right triangle, we always have the longest side opposite of 90 degree as hypotenuse. And there is this angle that we are going to care about. We are going to give the ratios about that angle. So there is this side which is opposite to angle and adjacent to angle. So we call this as adjacent right side because when we say adjacent in English, it also means the hypotenuse. They are both adjacent to angle alpha. But whenever I say adjacent, you should understand that it is adjacent right side. Later in future, I will say shortly adjacent side. Or we are in Kosovo right now. In your language, I think you have something like koishi. So I have memorized. It's a similar word in Turkish as well, komşu. Whenever we start with something like cosine and cotangent, we call these two. Whenever you start with those two, you always start with something koishi and also adjacent corresponds like koishi. If it is not starting with ko, if it is starting with other things, that means it is opposite. If it is starting with something else, it is opposite. So then anyway, if we write the ratios in this triangle, this was the hypotenuse. Now where I'm looking for angle A, opposite of it is A, hypotenuse is in this triangle C. And adjacent of angle A in this triangle is B, and hypotenuse is C. Tangent is opposite over adjacent, opposite of it A, adjacent of it is B. For the angle A, adjacent is B, and opposite of it A. Then we have this kind of questions. We are given the two sides. We don't know the third one. We find it by the Pythagorean theorem. You know, opposite of the 90 degree hypotenuse, square of it will be in the right side. The other two sides making the 90 degree, we are going to add their squares. 36, 64. That makes 80 x squared. It is 16 times 5. And you take square root of it, it will become 4 square root 5. So sine beta. By looking beta, the opposite and the hypotenuse, which is 4 square root 5. Opposite of beta is 4, hypotenuse 4 square root 5. When you simplify them, 1 square root 5. And cosine beta, adjacent beta 8 over hypotenuse 4 square root 5. When you simplify them, 2 over square root 5. Then tangent beta, opposite to beta, we have side 4, and adjacent to beta, we have side 8 and 1 over 2. Anyway, if we move forward, there are these two special triangles that you should have done them in 10th grade, also in 9th grade. So by looking this special triangle and the ratio of sides, we can write also these ratios for spatial angles 30, 60, and 45 degree. Anyway, let's remember this triangle. So there is a unique relation between the three sides if you have 90, 30, and 60 degree. If opposite of 30 is 4 centimeter, opposite of 98, opposite of 60, 4 square root 3. Or if the hypotenuse is 10 centimeter, opposite of 30 is half of it, 5, opposite of 60, 5 square root 3. And we have the ratio with 45 degrees that opposite of same angles should be same side, opposite of 90 always a square root 2. If one side is 3, the other one should be 3, and the hypotenuse should be 3 square root 2. Anyway, let's write the ratio. Sine 30. Opposite of 30 over hypotenuse, which is a over 2a. If you simplify them, 1 over 2. Cosine 30, adjacent 30 over hypotenuse 2a. If you simplify them, square root 3 over 2. And tangent 30, opposite of 30 in here, it's a, and adjacent of 30 is a square root 3. 1 over square root 3. And cotangent 30, adjacent of 30, a square root 3 over opposite of 30, a, it will be square root 3 over 1. I like to keep this over 1 over there. We may need it for some other examples. Then for 60 degree, opposite of 60 degree is a square root 3, sine is opposite over hypotenuse. Hypotenuse in this triangle, 2a, square root 3 over 2. And then cosine 60, adjacent 60, a over hypotenuse 2a, 1 over 2. Tangent 60, opposite 60 over adjacent 60, a square root 3 over a. If you simplify them, square root 3 over 1. Adjacent 60 and opposite 60. Cotangent, yes, sorry. Adjacent 60 in this case is a, sorry. I didn't check the triangle. When you simplify them, it will be 1 over square root 3. Then 45 degree, opposite of 45 degree is a, hypotenuse a square root 2. When you simplify them, 1 over square root 2. By the way, there is this idea, if you have radical number in the denominator, we don't want it to be there. We call that rationalizing denominator. You multiply it by the same thing. Square root 2 times 1 is square root 2 times square root 2 makes square root of 4, which is number 2. You may also see that in some results. Also in here, we have a similar case. We should multiply it by the same thing as square root, the same thing as the denominator. Square root 3 times 1 and square root 3 times square root 3 makes number 3. And cosine 45, it's also same. Adjacent 45 over the hypotenuse, 1 over square root 2, and tangent and cotangent are the same thing. Tangent, opposite of 45 over adjacent of 45. So after these two special triangles, there is this kind of examples that they want from us to solve this by using some trigonometric ratios. But it is better to use that special triangles to be able to solve these examples. And there is this first step, which is 30 and 15. So they are the two angles inside this triangle. If you add two angles inside one triangle, they are equal to, sum of them is equal to one angle outside of the exterior angle of the next corner. Anyway, that's 45 degree, then 90, 45, and 45 degree you get in here. That bigger triangle will become 90, and this corner 30, and the other corner is 60 degree. Anyway, in the small triangle, we should have the ratio 45, 45, AA, and hypotenuse A square root 2. So each side should be like number 2 in here, and this part should be number 2. If this side is number 2 in big triangle, what about this whole length down there? If opposite of 30 is 2, opposite of 60 should be, let's write the ratios of it, A square, A 2A, and opposite of 60 is A square root 3. 2A opposite of 60, A square root 3. In this case, A is equal to 2, so it's 2 square root 3. So the part X in here is equal to 2 square root 3 is the whole length minus this part. So then finding ratios for big triangles, for this reason, for this one, we use the unit circle idea, which is in the coordinate system, the number one, minus one, and minus one, we draw a circle that the radius is number one everywhere, every time. Wherever you draw, the radius is one. And with this one, we want to get the triangles, which is when I draw 120 degree in here, always starting from 0. There remains that 60 degree part in this part. And I can form a right triangle in here, 90, 60, and 30 degree. And the hypotenuse of this will be the radius, which is equal to 1. So with these ideas, we can get the trigonometric ratios, which is x numbers are giving us cosine, the y numbers are giving us sine. So this is the angle where it cuts the circle, the x number of it, cosine, the y number of it is sine. Anyway, firstly, let's do this part. If the hypotenuse is 1, we have the ratio between 30, 60, and 90 degree, A, 2A, and opposite of 60, A squared root 3. So 2A will be equal to 1, so 1A equals 1 over 2, which is this one. Then opposite of 60, this one times square root 3, which is square root 3 over 2. And with 45, 45, we have A, and A squared root 2. So A square root 2 equals 1. In this case, A equals 1 over square root 2. So let's draw this 120 degree one more time, and let's find the results of it. So the x number will give us the cosine. So let's make the 90 degree. If this is 120, there remains 60, 90, 60, and 30. Since the hypotenuse is 1, by looking here, opposite of 30 should be the length 1 over 2, opposite of 60 square root 3 over 2. Right now, I am trying to find the x number in here. Since it's the negative part is minus 1 over 2, that's giving us equal to minus 1 over 2 equals cosine 120, and the y number for this point, which is square root 3 over 2, it is a positive side, which is giving us sine 120 degree. So if I try to find the trigonometric ratio of some other angles, like in here, 240, 350, 150, let's do that. Let's remember these two triangles. 150, I will draw it in here. How much more do I have here for 180? 30. So here we have the point. The x number will show us the cosine. So place the numbers. 90, 30, and 60. Opposite of 30 will be 1 over 2. Since the hypotenuse is always 1, opposite of 60, square root 3 over 2. Since the length is square root 3 over 2, this number is minus square root 3 over 2, which is cosine 150 degree minus square root 3 over 2. And then this number will be positive 1 over 2, which is equal to sine 150 degree. When we ask you tangent 150, tangent is opposite over adjacent side. Opposite one is corresponding with 1 over 2, and adjacent one corresponding with the length minus square root 3 over 2. So you keep the first one the same, and you flip the second one, it becomes 2 over square root 3. By the way, plus over minus will be minus. 2 and 2 will simplify each other, which is minus 1 over square root 3, you can write. And For this kind of thing, since it will be like always 1 over 2 and square root 3 over 2, like over 2, you can directly simplify these parts over there. So they will be gone. You can directly write plus over minus. It will be minus 1 over square root 3. Let's do something like that, tangent of 315. So 315 degree is right before the 360. So 360, 315, if you subtract them, you will find that it's 45 degree. By the way, when you show the angles in here, let's say 240 degree in the previous triangle, always show the angles next to x-axis. I have shown the previous one next to x-axis, not the ones with y. In here, I am showing with x-axis, which is going to be 45 degree, and I want to find tangent 45 degree. With 45 degree, since the hypotenuse is 1, the opposite and the adjacent 1 over square root 2, both sides. 1 over square root 2, 1 over square root 2. So this number is in here plus 1 over square root 2. This number is in here minus 1 over square root 2. So tangent 315 equals opposite side corresponding with negative number minus 1 over square root 2. Adjacent side is positive 1 over square root 2, which is equal to minus 1. Then we have some identity questions also in the test, following test. And tangent and cotangent, the process that I just made in here, actually this opposite number, this is corresponding with sine, this is corresponding with sine 350, the y numbers are giving us sine, the x number are giving us cosine. If you realize that 350, which is tangent is equal to sine over cosine, the formula that you have here, tangent sine over cosine, cotangent cosine over sine. They are working exactly the same. When you multiply them by each other, sine over cosine, cosine over sine, they simplify each other and is equal to number 1. From this equation, you can write that anyway, one of them is opposite of other one. Cotangent goes to other side as division. So these two things, I don't think that you need to learn this, but they are like some additional things and they are working oppositely, which is secant is equal to 1 over cosine, cosecant, we call this cosecant, it's equal to 1 over sine. And then we have this identity, which is a very important identity. When you add sine squared plus cosine squared of any angle, they will be equal to 1. For example, sine squared 150, not 150, let's use something in the third quadrant. Sine squared of 180 plus 30, 210, plus cosine squared 210 degree. So we should find sine and cosine of 210 degree. 180 plus 30 more in here, always next to x-axis. Opposite of 30, 1 over 2. Opposite of 60, square root 3 over 2. So sine is the y number, is a minus 1 over 2 squared, plus cosine is the x number, minus square root 3 over 2, minus square root 3 over 2 squared. When you take squared, both of them will be positive, plus 1 over 4 square root 3 plus 3 over 4. When you add them, 4 over 4 equals to 1. Anyway, you must memorize this if you want to, of course. For the exam, you have to memorize. And from this equation, we can get the other ones. If you move cosine squared other side, instead of every sine squared, I can replace whenever I need by looking at the example. 1 minus cosine squared. Or if you move sine squared other side, instead of cosine squared, I can move, it will be minus sine squared. I can replace 1 minus sine squared x. So just want two examples about how to use them. So tangent x, there is this rule, tangent is sine over cosine. So cosine times cosine x times sine x over cosine x. You just write whatever you can. You just replace whatever you can. Later, they will probably simplify each other, sine x. In here, tangent x, sine x over cosine x, we can replace. Cosine x is the same thing, cosecant This is working opposite. If it is cosecant, it is 1 over sine. And this cosine x can be written as over 1. Then simplify the things you can. Cosine with cosine, sine with sine. Everything is simplified. In here, cosine and cosine cube. Cosine cube means cosine times cosine. So if you move one cosine x outside, from cube, you will have cosine squared x plus this cosine x will go outside, there will be sine squared x. So this was the formula that equal to 1. So cosine x times 1 is cosine x. The other one, just replace the things that you can. Sine x and cosine x, there is nothing to replace with them. We can write over 1 because I saw that tangent x, it will be rational. And cosine x over 1. And tangent x is sine x over cosine x. Division cosecant x, working opposite, cosecant 1 over sine, which is whenever starts with cosine x, I told you that you can make the ratio like coishi over hypotenuse. So they are like similar to each other, cosine and cotangent. So cosine goes, cosecant x, it goes by 1 over sine x. If you have secant in here, it will be 1 over cosine. Anyway, if we move forward, in here, these two will simplify each other. We will have sine squared x over 1. And also, this is a division in here. I will keep this upper number as the same. The lower number will flip. It will be sine x over 1. It is 1 over sine x. So it will be at the end sine cube x, sine squared times sine. So there is this thing also. The question is something like verify. But if they ask this in quiz or test, they will ask you simplify this part. They will not say verify. Verify means there is this given equation. We should confirm that yes, I mean they are exactly equal to each other. We choose a part to start with. For example, I'm going to start with from here, and I will replace the things that I can. Tangent is sine over cosine. Cotangent is cosine over sine. Cosine over sine. Then I need to make this addition. There is no other thing that I can do. I must make the denominator same. It's like 1 over 3, 2 over 5. 3 and 5 should be the same. So you multiply each by the opposite one. That's what I'm going to do in here. This one I will multiply by sine x up and down. This one by cosine x up and down. So sine x times sine x will be sine squared x. Denominator cosine x times sine x. Plus up and down by cosine x. Cosine x times cosine x, cosine squared x, denominator, sine x times cosine x. Now we have the same denominators, we can add the upper parts, but when you add the upper parts, you will see that sine squared plus cosine squared x, not sine 2x, is something really different. It's equal to 1, and denominator is sine x times cosine x, same. So there is this step that I skipped right now. Sine squared plus cosine squared is equal to 1. Also, this additionally, outside we have times cosine x. So these two can be simplified. Later you will have 1 over sine x. There was this opposite thing, secant and cosecant. They were working opposite. If it is sine x, it should be cosecant x. We can shortly show it as cosecant x. Thanks for listening. I hope you help me in the test.